चलें। So let's see, beta. What is Hoffman elimination? Beta, Hoffman elimination is another type of elimination in which you will get a Hoffman product as major. You will get Hoffman product as the major product. In earlier cases in E2 elimination, we have learned that ZZ is the major. ZZ is the major product due to hyperconjugation. You know? But here we don't see the ZZ as major, but whenever you have Hoffman conditions, so these are some cases in which you will get Hoffman elimination as the major product. So whenever you see these cases, you should know कि हमें Hoffman बनाना है. Let's say if you have a base is larger, you have bulky base. Let's say we have two bases. एक ये हमारे पास CH3 CH2O minus है, first base this one. Second base, if I have this tertiary butoxide, 3 carbon on single carbon, then we have oxygen minus. This is also as a base, act as a base. And if I increase the carbon on this base, this will act as a bulky. So bulkiness is increasing. Bulkiness is increasing from left to right. If bulkiness is increasing, so it cannot go and attack in the middle beach wala beta carbon, है ना? So it will go and attack outside only. It will take the outside hydrogen only, and it will show the Hoffman product. It will give us the Hoffman product as major. Understanding or not? So ये हमें Hoffman product major देगा. So more bulkiness is there, more the Hoffman product. And if I have, let's say here CH3O minus simple, and this is more small, this is more big, substrate increasing, this और बड़ा हो गया. So as we go, as the bulkiness is increasing, Hoffman product will become our major product. Hoffman products also increase with bulkiness. First case this one. Second case देखें. Let's say I have a double bond at gamma carbon, and this one is alpha, this one is beta, this one is gamma, है ना? जो कार्बन क्लोरीन के साथ अटैच है वो अल्फा, उसके साथ वाला बीटा, दिस वन इज गामा, है ना? So if I have double bond at gamma carbon, so what will happen? So it will try to remove this hydrogen in respect to this hydrogen. So out of these two hydrogen, ये वाले हाइड्रोजन को it will try to remove. अगर ये वाले हाइड्रोजन को इसने निकाला, फर्स्ट वन हाइड्रोजन को निकाला, है ना? So it will make here double bond, base will come, it will make here the double bond, and this one is the Hoffman product beta. Understand? So why this Hoffman product it is making? Because you have here conjugation, pi conjugation, pi का conjugation है. Therefore this Hoffman product will be made. And here no pi conjugation is there, but you have ZZ product. पर ये तो ZZ है, पर pi conjugation नहीं है. Therefore ZZ will be minor, and due to resonance pi conjugation, our Hoffman product will be major. क्योंकि conjugation आया, resonance effect, है ना? We will see always resonance in comparison to hyperconjugation, है ना? Resonance is a bigger effect than hyperconjugation. याद रखें. This is our second case. Third case, see. Let's say I have in the leaving group, I have fluorine, NH3 and NR3 positive, sulfur R2 positive, sulfur with alkyl halides, alkyl group, sulfur with alkyl group, positive charge. If I have these three leaving groups, you should always know that, agar let's say this example only, if I take fluorine here, अगर आई पुट एलिमिनेशन इधर E2 एलिमिनेशन करूंगा तो E2 करने पे मेरे को ये पता होना चाहिए दिस इज फ्लोरीन, वेरी डिफिकल्ट टू ब्रेक द बॉन्ड ऑफ फ्लोरीन, है ना. सो दिस बेस विल कम एंड विल अटैक ऑन द दिस कार्बन, this hydrogen of this carbon. So this one is alpha, this one is beta, this one is beta. So it has to take beta hydrogen, beta elimination, beta hydrogen चाहिए. तो ये वाले को it will be our Hoffman product will be our major and Setzer product will be our minor. And in these cases, understand. Here also, if I take these three example, so this one is alpha, this one is beta, this one is beta. See? So out of these three, अगर मैं ये करूं, so you all know these leaving groups are Hoffman leaving groups. Hoffman leaving group हैं तीनों. So you should make which product? Hoffman product. Hoffman बनाना है. So अगर मैं यहां से लेता तो मोर स्टेबल एल्कीन बनेगा, और यहां से लूंगा तो हॉफमैन एल्कीन बनेगा. सो आई हैव टू टेक दिस हाइड्रोजन इन रिस्पेक्ट टू दिस हाइड्रोजन. तो मैं यहां पर ये वाली एल्कीन बनाऊंगा. सो दिस इज आर मेजर, दिस इज आर मेजर प्रोडक्ट. डाउन ऑल्सो चेक, if I have this as alpha, this as beta, this as beta, so two possibility I have for beta hydrogens. So I can have this one or this one, but this one is the Hoffman, and you all know in NR3 positive you will get Hoffman product. So ये वाला product will be our major, other one will be minor. Last one also यहाँ पर देखें, this one also we have SR2 positive. In this also Hoffman product will be our major product. याद रखें बेटा. See, this is the case of bulkiness in bulky base. When you have a bulky base, big base you have, this base is very bulky base, है ना. Whenever you have bulky bases, like example यहाँ से start करते bulky base, tertiary butoxide. If I have this base, it will not give me Setzer product, it will give me Hoffman product. Always remember beta these all cases. Let's say this example also I am taking. Let's say I have chlorine here, है ना. यहाँ पर मैंने NH2 डाल दिया. You know, by seeing the reagent, you know it is elimination. NaNH2, alcoholic KOH, these are all eliminations. So once you do elimination in these, once you do elimination in this, what will happen? देखें. Once you do elimination in this, what will happen? क्या होगा? So it is alpha, this one is beta, this one is beta. You have to remove beta hydrogen. Here you have one hydrogen, here you have one hydrogen. But if I remove from here, I will get resonance, I will get conjugation. देखें, pi conjugation I get. But if I remove from here this hydrogen, so what I will do, मेरे को ये मिलेगा. And this is not pi conjugation, नको, इसमें नहीं है, इसमें pi conjugation ही नहीं है. अगर pi conjugation नहीं है तो भाई this product I won't get. So I will get Hoffman product in comparison to Setzer product. ये याद रखना बेटा. Where you will get Hoffman, where you will get Setzer, two rules are there. All the cases of Hoffman you should remember. Whenever you have bulky bases, when your base become bulky, it becomes very big. It can't go in between. वो अंदर जाके नहीं लेके आ सकता है ना. Is this you should remember. Let's say I have a leaving group as Br, है ना. Base will come and attack on the beta hydrogens, है ना. If it is making alkene in the side, less substituents on alkene, on alkene. This is known as Hoffman product. And you have more substituents on alkene. If you have more substituents on alkene, this is known as Setzer product. Always remember Setzer is more stable than Hoffman, but in some cases, special cases also I have told you today. All those special cases, first case you all know that your base is bulky. If your base is a bulky, let's say tertiary butoxide, then you will get Hoffman, then Setzer. Second case we have learned at gamma position you have double bond. Gamma position पे अगर आपके पास you have pi bond. Let's say this example if I took this example. Then your Hoffman is more stable. Third one we have seen today only. अगर if you have leaving group, in the place of leaving group you have fluorine Nr2 positive. R is what? Alkyl, and you have Sr2 positive. These three cases you will get Hoffman greater than Setzer. You will get Hoffman greater than Setzer beta. है ना बेटे? राइट yes or no, राइट इन द चैट बॉक्स अगर आपको समझ आया दिस थिंग, ओनली सिंपल दीज थिंग्स. Yes beta, only for double bonds Hoffman and Setzer. Yeah beta, समझ आया आपको? चले, should we shift to next thing? Don't worry beta, you will get these notes you will get. चल, let's say second type of example I am taking, which is even elimination. देखें, what is even elimination? E2 we have learned. Now this is even elimination. देखिए, what we have to do. Let's say I take an example, छोटा सा example if I take. Let's say I take an example CH3, CH, CH2, CH3. And if I have here bromine, है ना? If I put in this reaction KOH, K positive, OH minus, है ना? Let's say alcoholic KOH, and alcoholic KOH if I am putting in this reaction. So what will happen? क्या होगा? So first step will be in even elimination. First step, it happens in two steps. Even elimination happens in two steps. First step will be our rate determining slow rate determining step. So पहले step में क्या होगा? Bromine itself will go, है ना? Bromine itself will go, है ना? Because of solvolysis and removing of this bromine because of solvent, क्या होगा कि यहाँ पर positive will be made, carbocations will be made, and CH2 and CH3 will be made. So before attack of base, bromine is gone. And in that example also two cats we have seen. Before the attack of that yellow cat, that gray cat gone, है ना? Now what will happen? अगर इसके यहाँ से पहले ही चला गया, now what will happen? Now base will come and will take, this is alpha, this is beta. Now base can come and take beta hydrogen from here or beta hydrogen from this side, है ना? So two possibility it has. Let's say beta hydrogen A वाला ले लिया. So it will make what? Double bond इधर. So it will make double bond this side, one carbon, है ना? See this? Let's say B wala, base will come and take the B hydrogen, this hydrogen. अगर ये वाला लिया तो now it can make double bond here with the carbocation. It will make a double bond and carbocation is gone. CH3, C double bond, CH, CH3. So you will have two products also. And how many beta hydrogens you have, how many types of beta hydrogen you have, that many products you can have. है ना? So you have two beta hydrogen, two types of beta hydrogen, or two types of products you will get. So see, this is the Hoffman product and this is the Setzer product. And you all know Setzer is more stable than Hoffman. In simple cases, this is Br, nothing bulkiness, nothing more. In simple cases, Hoffman is more stable than Setzer is more stable than Hoffman. देख रहे हैं आप? See beta, even elimination you all know. Even elimination. You all have studied kinetics till now. आपने पढ़ा है कि rate is directly proportional to what? Rx power 1. Or I can write the rate of this reaction rate is equals to K alkyl halide power 1. This 1 shows us what? That the order of the reaction is 1. Order क्या है इसका? 1 है. Order 1 है. In this even elimination you will have to get an intermediate which is carbocation. Carbocation intermediate is made beta C. These are all things you have to remember beta in even elimination. Mechanism I have told you, mechanism, this is the mechanism. Mechanism लिख लें of even elimination. So what is the mechanism? Base will come, before base coming only Br minus leaving group will leave. Leaving group will leave first. Once leaving group is lost, carbocation is made. Now base can come and attack on this to give us. So this first step is very slow step. पहला step is the rate determining step. All those steps which are very slow will tell us is the reaction is going or not going. Is the rate determining? It will determine the rate of that reaction. Second step is very fast step better. The base will come now, it can take hydrogen and will make a double bond. And simple it is. So you know the carbocation is made. Once carbocation is made, it can go for rearrangement, ring expansion, ring compression. You all know. This all you know. देखें. See, rate of the reaction therefore depends on rate of reaction depends upon carbocation stability. Once carbocation is made, you have to see carbocation stability. Once in which transition states are made, you have to see transition state stability. You all know 1 degree carbocation, say 2 degree, then 3 degree carbocation is more stable. Then if you have allylic carbocation, or if you have benzylic carbocation, these are more stable. I have told you stability of carbocation. I have told you, है ना? देख लें. इवन एलिमिनेशन इसको यूनिमोलिकुलर एलिमिनेशन रिएक्शन कहते हैं. Unimolecular elimination reaction. Even elimination. So this is about what? Even elimination. Simple it is. Sure. I'm giving you 2 minutes. Beta, write this. Even elimination लिख लें. Write in your copy even elimination. So we are done with SN1, SN2, SNI. Then we have done elimination E2. Then we have done Hoffman elimination. Then we have done even elimination. समझ आया आपको? So let us start with some questions करें, देखें. Some questions मेरे लिए कर दें थोड़े से. चलो. Let's say I have this as fluorine and I put in this reaction alcoholic KOH. First one. देखिए कौन कर सकता है. Let's see who can solve. These are very simple actually, but I thought you don't have brains. This is fluorine. Second one only. If I have chlorine here, third one. If I have here, let's say, what to have? Here I have chlorine, but on the reaction I am putting H2O. चले स्टार्ट करें. Tell the answers, write the answers, beta. 2 minutes I will give. Write the answers. Anyone wants to tell the answer, they can unmute also and they can tell. किसी को आता है, they can unmute also and they can tell. You know. So first one, see. First one, see. It is given alcoholic KOH. This means it should be E2 elimination or even elimination. It should be elimination. even होगा या E2 होगा, है ना? अगर alcoholic KOH है तो elimination तो होगा. Then if you have fluorine, then you should know if the leaving group is fluorine, you should know it is Hoffman elimination. ये तो Hoffman elimination है. Hoffman है मतलब it can make from here alpha, beta, 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 है ना? So it can take hydrogen from this side, this side, this side. But which one alkene will be made? It can have this alkene. Another side also, if I make this side also, these two alkenes are same. But third one alkene will be this one. If I take from up, these two alkene are minor product because these are ZZ, but I want Hoffman. So this is our major product answer. मतलब alcoholic KOH ये वाला hydrogen it will take, this above hydrogen it will take and remove the fluorine. Down also check. Second one, if I do the E2 elimination in this, E2 करूंगा, अगर alcoholic KOH करूंगा यहाँ पर, so I can remove this hydrogen or this hydrogen. You have alpha, beta, beta. See? So I can remove these three beta hydrogens. So I have possibility, but which product will be made? Which product will be made? Setzer product will be made. So Setzer product will be our major because no condition of Hoffman is given. Simple it is, E2 elimination Setzer will be more major than or what? Hoffman. देखें, if you have done like this, then that is very good. Yes, beta, double bond out. Last one, see, if I have simple H2O, and this is 3 degree, this is 3 degree carbon and simple H2O. So H2O will what it will do? It will do the solvolysis. It can't do elimination. SN करना पड़ेगा. And out of SN and SN1 and SN2, which one I should do? Here, out of SN, this is simple H2O, not alcoholic KOH, not NaNH2, nothing. It is given, no base is given. So if it is simple H2O, so it will do SN reaction. Now SN has two types, SN1, SN2. Now you have to check the leaving group or substrate. So this, see, this is 3 degree substrate. Carbocation will be easily stable, है ना? SN2 नहीं हो सकता. SN2 नहीं हो सकता. SN1 it will happen because it is 3 degree. 3 degree पे हमेशा SN1 होता, SN1 होता. Understand? SN2 नहीं हो सकता. Steric hindrance is more here. It can't go and attack from backside and remove Cl. It can't do. But SN1 it can do. H2O will come and will try to remove Cl from outside. Cl को निकाल के लेके चले गए and will make carbocation. Now H2O can come. Now H2O can come and attack on OH2 positive बनाते. This we have learned in SN1. Now this another H2O, this hydrogen it will take and will make here what? Alcohol. याद रखें बेटा, for elimination you should see first the reagent. It is a base or nucleophile. If it is a base, go for elimination E1 or E2. If it is a nucleophile, then you have to see SN1. If SN, you have to see SN. So out of SN, you have to see it should go from SN1 or SN2. 1 degree will always go for SN2. 3 degree will always make 3 degree carbocation more stable. है ना। These all we will learn today. किसमें क्या होता है, किसमें SN1 कराना है, किसमें SN2 कराना है, सब कुछ आज सिखा देते। Today only we will learn. See last type of elimination नहीं, इससे पहले ये वाला देखें। See this example. आपको एग्जाम्पल दिख रहे हैं? These examples are for even elimination. Even elimination. Even मतलब आपको एल्काइल हैलाइड को पहले you have to remove alkyl halide, you have to make carbocation, then this base will come and will take the hydrogen and will make the double bond, है ना। So if I have tertiary, so this is the effect of substrate, so this is the effect of substrate on even reactions. So what is the effect of substrate on even reaction? मतलब let's say I have 3 degree carbon. This is 3 degree carbon, 1, 2, 3, 3 carbons attached. So in 3 degree alkyl halide if I have, you will get what? Even elimination, because you are getting stabilized carbocations. You are getting what? Stabilized carbocations. है ना? Carbocations are stable with 3 degree. Let's say this also, if I have allylic, and if I make here carbocation, this carbocation is more stable because it can go for conjugation between pi and carbocation, positive and carbocation conjugation, therefore it is also stable. So these all will, wherever you are getting stable carbocation and you have a base condition, you should have alcoholic KOH, NaNH2, these all bases, and you are getting stabilized carbocation, then only this alkyl halide will go and remove and it will make a stabilized carbocation. Now base can come and take hydrogen to make it, है ना। So this is 2-step reaction. Third one, see, if I have benzylic, if I have aryl group, phenyl groups, so this carbocation will be made here. Now base can come and will attack on hydrogen to make double bond here. See, last one also, see, let's say I have alpha hetero substituted atom, मतलब यहाँ पर अल्फा के कार्बन पे you have hetero atoms, so this is plus M effect plus mesomeric, है ना। If some carbocation is made here, so oxygen can donate to positive easily, है ना, by resonance, by mesomeric से दे सकते हैं ये easily, and that carbocation will be more stable. Here. Now this hydrogen can go and will make a double bond. Now base can come take the hydrogen and will make a double bond here. So these all cases are even elimination. These all cases are for even elimination, where you are getting stabilized carbocation after removing of halogen. Third one, see, if you have secondary, if you have 2 degree alkyl halide, so substrate can go by E1 or E2 both. So basically dependent upon solvent and other condition, you can do E1 and E2 both, है ना। So let's say यहाँ पर carbocation बन गया, this is 2 degree carbocation, now this is made by even elimination here. Done. Last one, see, if I have simple primary 1 degree alkyl halide. So अगर primary alkyl halide, it will never make a stable carbocation, therefore even elimination कभी मत कराना primary alkyl halide में. If you have 1 degree CX, never do even elimination, क्योंकि stable carbocation ही नहीं है. Because there is no stable cation, there is a unstable carbocation, है ना। So we can't make carbocation here and we can't do even elimination in primary substrates, primary alkyl. Understanding or not? And you should remember this all better. Let's say simple this also. Substrate that cannot eliminate by other mechanism, no appropriate placed hydrogens they have. Let's say this also. If I make here, if I make these substrate, let's say Inca elimination, if I want to do. So if I make carbocation, from where it will take hydrogen now? No beta hydrogen. No beta hydrogen. Here also, if I make carbocation, where is the beta hydrogen? This is phenyl ring. Phenyl ring है ये तो. अगर यहाँ पॉजिटिव बन गया, ये कहाँ से बीटा हाइड्रोजन लेके एलिमिनेशन करेगा? नहीं करता. See this also, if I make carbocation here, there is no beta hydrogen on beta carbon, no beta hydrogen. So therefore they cannot be eliminated by E2 mechanism, और E1 से भी नहीं कर सकते. So here elimination we cannot do. So necessary condition for elimination is we should have beta hydrogen. Understanding or not? Simple these things are. Again I am repeating first. See if I have tertiary 3 degree, you can have stabilized. Wherever you have stabilized carbocation by any effect, you will always go through E1. कार्बोकेटाइन स्टेबल होता तो E1 करते. बस बेस होना चाहिए आपके पास. यू शुड हैव बेस. डन. अगर कार्बोकेटाइन स्टेबल नहीं है तो फिर E2 होगा. सिंपल. अगर प्राइमरी कार्बोकेटाइन है, प्राइमरी कार्बोकेटाइन कभी नहीं बनाते. We cannot make primary carbocations because these are unstable carbocations. So even elimination we cannot do in 1 degree alkyl halides or 1 degree carbocations we can never make. Last one, see, if you do not have beta hydrogens, you cannot do elimination. If you don't have beta hydrogen, you cannot do elimination at all. Done. So this was the story of even elimination. Even elimination की story है, कार्बोकेटाइन की story है. Done. So with this, we will go to our next thing. Write yes or no in the chat box. जिसको समझ आ गया है yes or no लिख दें चैट बॉक्स में. चलो. Okay. New mechanism we will see today. This is known as even CB. है ना? We studied E2, we studied E1. Now this is even CB. Even CB stands for unimolecular. Even CB stands for unimolecular elimination with formation of conjugate base. This CB stands for conjugate base. Unimolecular elimination conjugate base, even CB. है ना? So see, in this reaction also order is always 1. Rate is directly proportional to concentration of conjugate base. Or rate I can write is equals to K times rate constant conjugate base. See what will happen here in even CB. Let's say I have a base as OH minus. This is my leaving group. This is my leaving group. This is my leaving group X alkyl halide. This is my alpha carbon. This is beta carbon. And if I have beta hydrogen, So what will happen? This base will come and take the beta hydrogen, will make the double bond and will shift the double bond of carbonyl CO on oxygen, because oxygen is more electronegative, it can take electrons on himself. तो इसने यहां पर आके हाइड्रोजन को लिया, मेक अ डबल बॉन्ड, शिफ्ट दिस अप, है ना, यहां से इसको पुश, है ना, इसको पुश किया, इधर से इसको पुश किया, हाइड्रोजन के इलेक्ट्रॉन्स इधर शिफ्ट किए, इसको अप किए, डन. सो नाउ दिस इज नोन एज व्हाट? स्टेबलाइज एनायनिक इंटरमीडिएट. ये इंटरमीडिएट, व्हाट इंटरमीडिएट इट विल मेक, देखें. So let's say hydrogen को ले गए, so it has made here conjugate base. This is an acid, this act as an acid because it has given H positive, this act as a base, है ना. So if some acid is there, their substrate will be known as conjugate base, है ना, उसका conjugate base, है ना. Let's say we take example of HCl. HCl will give you H positive and Cl negative, but Cl minus is known as conjugate base of HCl, है ना. एसिड का क्या होता? कॉन्जुगेट बेस होता. So Cl minus is conjugate base of HCl. Similarly, this is the conjugate base, this is our intermediate. Once this intermediate is made, now O minus will come and attack on this double bond, make a double bond here. This double bond will shift forward and this leaving group now will leave, है ना. So this effect is known as push-pull effect. Push-pull मतलब पहले यहां से पुश किया ऑक्सीजन के ऊपर, देन ऑक्सीजन ने यहां से, ऑक्सीजन ने इसको एल्काइल हैलाइड को निकाल दिया, है ना. ऑक्सीजन ने इस एल्काइल हैलाइड को निकाल दिया. सो ऑक्सीजन ने यहां से पुल किया अपना, यहां से पुल करके एल्काइल हैलाइड, द लीविंग ग्रुप इज रिमूव्ड फ्रॉम. So we will make here, this compound is known as alpha beta unsaturated alkene. This is known as alpha beta. So this one is the carbon, इसको alpha कहते हैं, इसको beta कहते हैं. Alpha beta unsaturated alkene we make in E1CB elimination. So these examples I will take today. देखें, let's say I have here, wait, right, this 2 minutes I am giving to you, E1CB लिख लें, then I will tell you new example. Right, this 2 minutes I will give you. Right, right, Peter. After writing, write yes or no in the chat box. After writing, write. This only we will learn better how we will identify E1, E2, E1, CB. चल said, let's say even CB. So what will happen first in even CB? Deprotonation will happen first. देखें. So in even CB, deprotonation means removal of hydrogen will be done. है ना? Carbon ion, this carbon anion is our intermediate. Negative on carbon will be our intermediate. Now it can go up here. यहाँ से ऊपर जाके चला जाता. Then it can go come back and will remove the leaving group. Will remove the leaving group from here. Second case we have learned simple was E2 elimination. Concerted mechanism. Single step. Concerted mechanism, single step. है ना? Base will come from anti of this. H and X should be anti. These should be anti to one another. Opposite होने चाहिए. Base will come from anti. Take the hydrogen, make the double bond, remove the leaving group. This is E2 elimination. Deprotonation and loss of leaving group simultaneously. So first step is deprotonation, removal of hydrogen from beta carbon. This is alpha, this is beta. Deprotonation and loss of leaving group simultaneously. Third one you all know. First is even elimination. Leaving group will leave first. Leaving group chala jayega pehle. Will make carbocation. Now base will come and attack on hydrogen to make double bond. Now base will come and attack on hydrogen to make double. Understand? These all three cases, see beta, these in all the three cases, products are same. Products are same. All the three cases, products are same. See, reactants also same. See this reactant, this reactant, this reactant, reactants also same. But if you have here, if I can on beta hydrogen के साथ वाले कार्बन पे, if some stabilizing effect is there, है ना, something like -m effect, like NO2, CO, CHO, or CO, है ना, if you have NO2, CO -m effect on the adjacent carbon to बीटा कार्बन, एडजेसेंट कार्बन टू बीटा कार्बन पे यहां पर कोई अगर यहां पर दिस स्पेस, दिस कार्बन ऑन दिस कार्बन, इफ आई हैव on this carbon, if I have -m effect, so it will try to stabilize this anion, है ना, anion ना, कार्बन आयन, नेगेटिव चार्ज, अगर नेगेटिव चार्ज को स्टेबल करना है तो यू हैव टू टेक नेगेटिव from negative electrons, है ना. So -m इलेक्ट्रॉन विड्रॉइंग इफेक्ट ले लिया, इसने अपनी तरफ लिया. Now oxygen can give again and will remove the leaving group as above we have shown, है ना. So this CO will act as a -m group, -m, है ना. इसने अपनी तरफ ले लिया और यहां से अटैक करके X को निकाल दिया. समझ रहे कि नहीं? But if you don't have -m group, you have simple alkyl halide with beta hydrogen. So this is concerted mechanism. This is concerted mechanism. You can go by backside attack, anti-attack of hydrogen and X, and you can make alkene. But third case, if you have even elimination, always remember in even elimination, if you have stabilized carbocation, if you have stabilized carbocation. In above cases, we have seen all the cases of stabilized carbocation. 3 degree tha. In above table, we have seen all these. ये वाले. We should have tertiary, allylic, benzylic, alpha heterosubstituted. These all are stabilized. These all are stabilized. अगर stabilized है तो it will go for even elimination. है ना? So first thing you have to check कि बीटा फर्स्ट थिंग दिस इज अल्फा, दिस इज बीटा. फर्स्ट थिंग यू हैव टू चेक कि बीटा कार्बन के साथ में कोई माइनस एम ग्रुप ना हो. If there is minus M group, there will be even CB elimination, even CB mechanism. Second thing you have to check if the carbocation, if you are removing halogen, if that carbocation is stable or not. If it is 3 degree allylic, benzylic, alpha halo substituted, these all are stabilized. So it will go for even elimination. है ना. अगर even CB नहीं है, even भी नहीं है, stable carbocation भी नहीं है, then you can go for E2 elimination. समझ रहे कि नहीं, है ना. So first check even CB, even then E2. Final answer E2. Always go through E2. If you have less stable carbocation, go for E2. Understanding or not? So this was all about even E2 and even CB mechanism. See, these all three are mechanism, but our reactants and products are same. So let's take one more example. देखें. If you can see from here, see. So this is a chart which will tell you, which will have even CB, which will have this, which will have that. Let's say I take strong base, and like DBU, DBN, tertiary butoxide, NaNH2, है ना, like alcoholic KOH. This I take, है ना. So these all will have a tendency for elimination. So you have, let's say, primary, है ना, तो प्राइमरी में E2 ही कराएगा. मिथाइल में E2 नहीं करा सकता because no hydrogen. You cannot make simple CH3 double bond, है ना. So you have to do SN2. You have to do SN2 because no beta hydrogen. No beta hydrogen. But in rest, you have to do elimination with these nucleophiles, strong basic nucleophiles. Like NaNH2, alcoholic KOH, DBU, DBN, tertiary butoxide, ये वाला tertiary butoxide, है ना. More bulkiness will be there, more it will be basic. More bulkiness, more basic. Hoffman product. Understanding or not? Let's say you have less hindered nucleophiles. Let's say we have CH3O minus. And a hindered matlab steric hindrance. Hindered matlab steric hindrance. Small. Unhindered matlab small. Hindered matlab very big. है ना, bulky. Bulkiness. है ना. Hindrance. It is giving us the hindrance. So let's say this is there. On methyl, if I have to do, you can do SN2. Easily SN2 you can do. You can go backside attack करके SN2 leaving group को leave कर सकते. Second case, if I have this primary alkyl halide unhindered, you can go do SN2 easily. But if you have hindered मतलब यहाँ से attack करने के लिए आए, but these are giving me hindrance. These CH3 are giving me hindrance. So here E2 can also be done. Elimination you can do beta with CH3O minus. Let's say you have secondary. So secondary may, if you have this base, it will go for E2. This will act as a base. This will act as a base. Always remember in SN reaction, the reagent will act as a nucleophile, but in elimination it will act as a base. Base will take H positive. Nucleophile will attack on carbon to remove the leaving group. See, if you have 3 degree alkyl halide and you have CH3O minus written on the arrow, you will do E2 elimination. E2 elimination. And last is if you have beta to anion stabilizing group, let's say you have any minus M group here. This negative this hydrogen, any base will come and take, you have any minus M group, anion stabilizing group, which can stabilize this anion, you will have even Cb. Anything you have, you should check first the even Cb. First check even Cb, then check strong basics. Strong basic one check. If you have strong base, do E2. If you have strong base, always do E2. याद रखें. If you have strong base, always do E2. Always. If you have anion stabilizing group minus M group, always do even Cb. If you have strong base, always do E2. Then for these cases, you have to check. In these cases, you have to check now. In these cases, you have to check here. देख लें. In these cases, you have to check if you have CH3O minus, or if you have weak nucleophile like I minus, RSH minus, and poor nucleophiles are solvents. All solvents are poor nucleophiles, in which you have to check SN1 and SN2. Simple one. SN1 and E1 you have to check. If you have poor nucleophiles, SN1 and E1 will go. Nucleophile is very poor. You have to check the stability of carbocation. 3 degree में और 2 degree में stable है carbocation. Therefore SN1 and E1. है ना? So this table will help you to tell you. This table is very good table, beta. It will help you to tell where SN1 will occur and where E1 and E2 will occur. Oh, sorry. देख लें. So write in your notes this table. Draw in your notes this table, beta, today only. लिख लिया आपने? Write yes or no in the chat box. The main thing you have to see that the reagent which you are using, it is acting as a base or it is acting as a nucleophile. If it is acting as a nucleophile, you will do SN reaction. If it is acting as a base, you will do E2 elimination. We start. चले बेटा, you will get these notes, don't worry. चले, first question we will start. चलो, one by one we will solve some question today. First question, let's say which of the following alkyl halides will give only one product. Beta, focus on screen, beta. Now focus on the questions. When E2 reaction is done, which of the following alkyl halides will give only one product? मतलब only one product you will get during E2 elimination. First one, A, this one, B, this one, C, ये वाला है, and D. Write in the chat box answer. आंसर लिख दें. आंसर लिख दें out of ABCD. What is the answer? Tell me which of the following will give only one product. Means it should have only one beta hydrogen. बीटा हाइड्रोजन बीटा कार्बन एक ही होना चाहिए दोनों साइड से. देखें आंसर्स आई एम राइटिंग हियर. आंसर आई एम राइटिंग. फर्स्ट वन, see if you have A, here chlorine, it can have three product beta because it has three beta carbon, 1 2 3, and it can have this product, it can have from here another one, it will be same, so it will have two products. Second one, see if I have this chlorine, I can remove from this side two beta carbons it have, so I can have this product or I can have this product. So here also two products. Third one, see if I have chlorine this side and this side, it also has two beta carbons, hydrogens also they have, so ये वाला बनेगा या तो ये वाला बनेगा. So इसके भी दो प्रोडक्ट है, both are different. Last one, check if I have chlorine here, so if I take from here or here, same product will be made. See this or I have this and this, these two are same beta. If you rotate them 180 degree, so only one product is. These two are same. So answer are correct is fourth option. समझ आ रहा है कि नहीं? Simple it is. Write yes or no in the chat. Yes or no लिख दें. चलो. Second question. Question number 2. Let's say I have this alkyl halide. I will do E2. So you can get one as Hetzer product and other as Hoffman product. If I remove from here hydrogen, it is Hoffman. If I remove from here, it is Hetzer. Then देखें, this is Hetzer, this is Hoffman. So I am giving you first question in this. This is second question. इसका first part, second का first part. Which of the following, which of the following leaving group will give maximum sets a product? Which of the following will give you maximum sets a product? Let's say first one is X is equals to iodine, then Bx is equals to fluorine, third one X is equals to chlorine, and fourth one X is equals to bromine. Tell the answer. Out of these four, which one is the best leaving group? A. Iodine is the best leaving group. Therefore, iodine will give me maximum Setzer product. Very good. Same question, repetition of this question I am doing. Yeah, I will show you one magic today. The same question, which of the following leaving group will give you maximum? Next question is maximum Hoffman product. Same question, options are also same. Now tell me out of A, B and C, D, which one will give me maximum Hoffman product? Tell me out of A, B and C, D, which one will give me maximum Hoffman product? Write in the chat box. I will also come to know that you know or not. Hoffman कौन सा देगा इनमें से? Hoffman will be given by who? It will be given by fluorines, है ना? आपको पता है fluorine? If the alkyl halide is fluorine, Hoffman will be given by fluorine. चल. So you will get maximum Hoffman product with if you have fluorine on this. Third question will start. चलिए third question देखें. Let's say I have CH3 above and OH. Let's say here I have chlorine and I have OH minus and heating I am doing. यहाँ पर आप ये लिख लें, यहाँ लिख लें आप alcoholic KOH. Now do. So if I am doing this reaction, so if you have four options, first option I am giving you. You all know if there is alcoholic KOH there, you have to do E2 elimination करना है. E2 कौन सा करना? E2 करना है तो कौन सा ऑप्शन बनेगा? A, B1, this one, C is this one, and D is this one. चले बताएं. Write the answer. A, B, C, D में बताएं which one is the correct? Right, beta, everyone write. Don't wait here. Don't wait for anyone. Write. Write your answer. It is wrong or right, I don't know, but write. Everyone will write the answer. Everyone will write the answer, beta. Write in the chat box answer, right? Right, everyone write the answer. See, if you have to do the E2 elimination, you can do E2 elimination. This is the alpha carbon with chlorine. This is beta carbon, this is beta carbon. So I can take hydrogen from here, I can take hydrogen from here, two possibility. But the hydrogen should be anti-elimination hona chahiye. See, if this CH3 is above, if this CH3 is above, what will be down? Down will be hydrogen. What will be the down one? Hydrogen will be down. But this hydrogen and Cl are not anti. They are same side. They should be opposite to one another. एक दूसरे के opposite होने चाहिए, है ना? ये तो दोनों एक साथ हैं. So this alcoholic KOH base can't attack on this hydrogen. And this first answer is wrong. So A answer is wrong. So what it will do? It will take the hydrogen here. देखें. Because CH3 was above, if CH3 was above, you all know hydrogen will go where? Right down. Now here I have two hydrogen, one above, one below. है ना? So I have to take this hydrogen because I have to do by anti-elimination. Now I can do here this and I can do OCl. है ना? This only I have to do. So which alkene I will make here? This one, and this one will be RCH3. समझ आ रहा है कि नहीं आपको? So our answer will be B. So those who have told B, Samruth has told B, Tejal has told B, and Kishan Verma has told B. Very good. Sure. Next question, see. Let's say I have bromine down, CH3 up, here also CH3 up, and I put in this reaction Na positive OCH3 negative in the presence of alcohol CH3. क्या करें यहाँ पर? Answer tell. Options I am giving you. First option, this one. By options only, you are coming to know that this is elimination, not substitution. एल्कीन बन रहा है तो एलिमिनेशन ही होगा. Tell me out of the four which one is correct option. See, bromine minus is back. So this is alpha, this is beta, this is beta. So I want on beta hydrogen, we should be up. We should be up. We should be up. So I want someone to come from up and take the hydrogen and down, make double bond. So see, in these two, both the hydrogens are down. Both are same side, sin. Both are same side, sin. So he cannot go and take these hydrogens. He cannot go and take these hydrogens. So answer will be what? D. Answer will be D. Check. देख लें. Because it cannot take, because you have to do anti-elimination. Because you have to do anti-elimination. Because you have to do anti-elimination. अब एंटी होने के लिए हमारे पास यहाँ पर एंटी होने के लिए आई नीडेड हेयर I need here what? I need here hydrogen. I need here beta hydrogen which is anti to Br. I need here beta hydrogen which is anti to Br, but I am not getting anywhere. You know? This was the base here. है ना. अगर मेरे को यहाँ से इसके हाइड्रोजन चाहिए बट बोथ आर बिलो, बोथ हाइड्रोजन आर बिलो बेटा, सेम साइड. सो इट कैन नॉट डू E2 एलिमिनेशन. E2 तो नहीं कर सकता भाई. नको नहीं. अंडरस्टैंडिंग or not? Sure. See question here also, one more question. This is which third, fourth, fifth one we will solve today. Let's say I have this compound. Here I have NO2 group. Here you have chlorine. Now you put in this reaction, let's say OH minus. See, this is an example of, even CB. How to tell it is an even CB? That if you have alpha and you have beta, at beta carbon you have some groups which are minus M groups. Done? So what will happen in this? So this hydrogen will be lost. This hydrogen will be lost by OH minus. ये यहाँ से hydrogen लेता. It will go for resonance with NO2. Now NO2 will push back, make double bond here, will remove the Cl. है ना. देखें, I will show you. I have also not drawn this anytime. देख कैसे बना. See, N double bond O and here 2 NO2. है ना. This hydrogen he has taken, made here double bond. This double bond will shift to oxygen. देखें. यहाँ पर ये ऑक्सीजन पे शिफ्ट हुआ, यहाँ पर डबल बॉन्ड बन गए, यहाँ पर Cl बन गया. नाउ O नेगेटिव विल कम, मेक डबल बॉन्ड. दिस डबल बॉन्ड विल शिफ्ट ऑन दिस सिंगल वाला और Cl माइनस विल रिमूव एज Cl. क्लोरीन विल रिमूव एज Cl माइनस. देखें, आर प्रोडक्ट विल बी double bond came here, NO2 will be here, and now these two benzene rings are yes. So this is our product beta, and this is known as even CB mechanism. देख लें. देख ले बेटा. Write this in your copies. Done. Let's say one example more I will take. देखें ये example. Fifth, sixth one. Sixth one example, see. Let's say I have here this bromine this side and this S. And I put in this reaction ETOH. I put in this reaction ETOH. So reaction will go through beta in this mechanism. Reaction will go through even mechanism. Even. Because carbocation, if this is made, this is 2-degree carbocation. So this 2-degree carbocation go for rearrangement. And we will see the answer today. Solution we will see better. How to do. Sixth. Now if you know, it is going through even elimination. So even में क्या होता? You have to make this bromine. First step is our rate determining step. First step is our rate determining step. We will make carbocation. Even elimination. Once this carbocation is made, you can go for ring expansion. There is no ring compression. There is no ring. Then you have to go for rearrangement. This is 2-degree carbocation. Rearrangement करके क्या करेंगे? 1,2 methyl shifting. I have told you if you have 2-degree carbocation, you can go to 3-degree carbocation. कैसे? By methyl shifting. तो ये वाला CH3 will go and shift towards this carbon. तो ये वाले 2 कार्बन के ऊपर, now it has 2 carbons here. It has 1 again, and this carbon will go as CH3 minus. Minus का के positive पे चला गया and will make here. Done. Now carbocation is made here. This becomes 3-degree carbocation now. So therefore rearrangement is done. After rearrangement, what will happen? ETOH will act as a base. Now elimination हो गया है, positive बन गया है. Now what it will do? It will take, this is alpha, this is beta, this is beta, this is beta. So it has to take hydrogen from beta carbon. So it will take this hydrogen because more stable alkene will be made. Understanding or not? So answer ours is this, है ना? देखें आप स्पेशल, अब यहाँ पे नो, देयर इज नो बीटा हाइड्रोजन, देयर इज नो बीटा हाइड्रोजन, therefore it has to go by even mechanism, therefore it has to go by even mechanism. Here no beta hydrogen, this is alpha, this is beta, यहाँ पर बीटा ही नहीं है. If you make here beta, if someone is trying to make here double bond, this will be less stable. Hoffman it will be, but we are getting more stable. Understanding or not? Sure. So question number 7. If I put in this reaction alcoholic KOH, tell me the products. You have to tell. Find number of E2 products including stereoisomerism also. Including stereoisomers. Include the stereoisomers. And let's say you are making double bond, it will be E and Z both. And it can have E, it can be Z, or if there is a possibility of chiral carbon, it can have R or S. So tell me number of products first and then check EZ and RS. Or 2 power N also you can do. And to find total number of products. Write the answer, beta. Write the answer in the chat box. Prize money will be given to the one who will write the correct answer. Write the answer in the chat box. Prize money will be given. Now only it will be given who will give the correct answer. Answer 10. Yeah, it is 5, 6, 7. How many? Tell answer 10. Write the answer. Last question it is for today's class. 6. Someone is telling 6. Someone is telling 5. Someone is telling 4. Sure. So let's say this is alcoholic KOH. If we have to do E2 elimination, है ना? Alcoholic KOH है तो आपको E2 elimination करवाना है. कैसे करवाते हैं? This is alpha. Let's say again I am writing here bromine here. This is the solution. 7th question. So if I have alcoholic KOH, what I will do here? This is alpha, this is beta, and this is the beta. This carbon is alpha, इसके beta, 3 betas it has. So it can make how many alkenes? 3 alkenes. From here if I take hydrogen, double bond here, bromine remove. Here से लिया, यहाँ से double bond here, bromine remove. From here, double bond here, bromine remove. है ना? So first this possibility, let's say ये वाला, let's say beta 1, beta 2, beta 3. This one is first one. Second one से अगर निकालें हम, this one is the second one. And third one से निकालें हम अगर, see third one is this one. Check. Check, check, check. Something wrong or not? Yeah, something wrong. One carbon left. Yeah. So see, all the alkenes are different. All the three are different to one another. See there, 1, 2, 3, 4, 5, 6 different name. And 6 hex ene. 3 you have methyl. Here also check. Now check chiral carbons. No one has chiral carbons. Now check EZ. Geometrical isomerism check. Geometrical isomerism in first check. This group and this group are totally different. This group and this group are different. So EZ is possible here. This one, see it has 2 hydrogen. EZ not possible. है ना? So इसके EZ होते हैं तो मतलब one will be E, other will be Z. So 2 geometrical isomerism here. 1 here. And यहाँ पर भी check करें geometrical isomerism. EZ check करें. This is one is hydrogen. This is another group. This is hydrogen. This is CH3. This is C2H5. This also geometrical isomerism possible. So 2 products here. E and Z. So how many total products? 2 from here, 1 from this one, and 2 from this one. Total 5 products. Total 5 products is the answer. So number of E2 products are 5. And those who have given 5, tell the name. Charishma told 6, Nihar 5,